Hey, what is up, everybody? Here's our first video for these next upcoming weeks. This is for this week, week 1 of suspended school. This is confidence intervals and the basics. Before going through this video, I highly recommend that you get the notes from the website. At least either it's been emailed to you or it's been mailed to you. There's a packet for the 8.1 confidence intervals notes. This video is going to go along with all of that. And what we're going to be talking about are 1 proportion z intervals. You need to start associating proportion with z as we go forward. And there's going to be various different types of intervals. We'll go into t intervals, 1 proportion, 2 proportion, 1 mean, 2 mean. Lots of good stuff. So we'll start off with the simplest 1 proportion z intervals. So that means we're using sample statistics to estimate population parameters. Now you need to know your vocabulary pretty well for all this, and let's do a quick review. Know the difference. A statistic describes samples and a parameter describes population. We've talked about proportions and means for the most part. We're just going to focus on sample proportions versus population proportions, and our goal is to use sample proportions to estimate the actual population proportion, because as we know in real life, it is very hard to actually estimate things for an entire population, to actually get exact numbers, so we're going to use samples to help us estimate it. Where we might be using this stuff, for example, let's say that a survey of a large sample of voters shows that 52% plan to vote for candidate A in the upcoming election. Can we use this statistic to estimate what proportion of the total population of voters will vote for candidate A? Obviously, we have this survey that was done of a large sample, and we want to extrapolate this data to kind of predict how the actual election is going to go, assuming that this is a well-collected sample. And that's where confidence intervals would come in. We're going to create a confidence interval, and in order to do any confidence interval, we need a point estimate, which is a statistic from a sample, and we need a margin of error, which is calculated based on the sample size. So in this particular example, we have maybe our particular point estimate, the statistic that was given, and a margin of error that we have estimated. We collected the sample, and we're saying there's a margin of error of about 3% plus or minus. That's our confidence interval. We can say, using that statistic, that we predict the actual population proportion of people who will vote for this candidate to be between 49% and 59%. Where that plus or minus 3% comes in. That's the confidence interval right there. So 1 proportion z intervals, what are they? We have our statistic, our point estimate, our p-hat, and then we have a margin of error. To calculate margin of error, we need z star times some standard error. And then in order to do that, we keep simplifying that formula and we get this large thing. Our p-hat plus or minus z star times the square root of p-hat times 1 minus p-hat all over n. Again, these formulas will be given to you, especially that standard error formula for proportions. And yes, you can do all of this on the calculator, but you do need to know the math behind it to answer some questions. You will have to show your work, at least, not particularly the mathy part of it, but at least writing the formula and then plugging things in. And then you can use a calculator to do the actual hard math. So let's take a look at example 1 from our notes local newspaper. The Houston Chronicle polls a sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget. Create a 95% confidence interval for actual sentiment of all voters. Interpret your confidence interval. So step 1 of doing a confidence interval is first assessing what are we given and what are we doing. We're given some interesting number x that we'll call 144. We usually use x to represent the number of successes. The sample size was 330. That gives us a p-hat of 144 over 330. And we know that we're going to be doing a 95% confidence interval. Specifically, we have 1 proportion that we're interested in. So it is a 1 proportion z interval. Anytime we deal with proportions, it's going to be a z interval, and I'll explain where the z comes from momentarily. Step 2, are the conditions met? And in our notes, I list 2 major conditions. The first one has 2 parts to it. Is it random? And yes, they tell us that the poll was a random sample. And is it independent? Remember the test for independence from all the past stuff was that 10% rule. Your sample size has to be less than 10% of the total population. And we can pretty much, say that 330 is less than 10% of the population of Houston voters. The large counts condition, that is taking your sample size and multiplying it times p hat and checking if that's greater than or equal to 10, otherwise known as the number of successes. And n times 1 minus p hat is also greater than or equal to 10, the number of failures. That's pretty easy. We know we got 144. That's n times p. That's greater than or equal to 10. And same thing with the other. We get 186. That is also greater than or equal to 10. So the large counts condition is met. Both conditions are met. We can proceed. So next step, set up the formula and plug in everything. So here's our formula that's been given to us. Since this is a 1 proportion z interval, we know p hat and we know n. So we can go ahead and plug in those numbers, p hat being the 144 divided by 330. But now we need to know z star. That is the last part of our equation that we don't know yet. No huge calculation to get z star. In another video, I may kind of cover where z star comes from, the whole theory behind it. But right now, I just kind of want to get through what we need to. And I'll tell you right now that z star, to find it, look at the bottom of table B on the formula sheets. I did include some formula sheets in the packet that is emailed or mailed to you, and it is also on the Cardenas Math website. But if you take a look at table B, you go all the way to the bottom, and you'll see confidence levels next to the infinity symbol on the degrees of freedom part over there. We look at our confidence levels, and those numbers above it are the z stars that we're doing. Since in this problem it is asking for a 95% confidence level, z star is going to be 1.96. Easy enough. I'm going to go ahead and plug that in. I don't know why I put 1.95. Man, I messed up. It's okay. We'll keep going. Assume that's a 1.96. Anyways, plug it into my formula and then break it up into 2. Notice that we have this plus or minus right here. So that means we're doing our formula twice. We subtract and we add. And we're going to end up with 2 numbers. 0.38286 and 0.48987. That is our confidence interval. Pretty much. Now, how do we interpret that? That is the last thing, draw a conclusion. And this exact wording I put on your notes, and you pretty much have to fill in the blanks every time you do this and wrap up your problem with this statement. We're 95% confident that the interval from 0.38286 to 0.48987 captures the actual value of the proportion of voters who will vote yes on the upcoming school budget. You always answer in context. You take what's kind of given to you and you reword it to kind of wrap up your answer in something that makes sense. So that's the confidence interval. We have some interval that we're saying the true proportion of voters that will vote yes will fall somewhere in here. Doesn't really tell us much. There's about a 10% difference in here. But that's all we can really do. And notice that it says 95% confident on here. The higher your confidence, the bigger the interval is going to be. And the smaller your confidence, the smaller your interval is going to be. So you'll start noticing a relationship between them as we go through more lessons. But usually the confidence level is given to you and you use that to find z star. And that's how you answer your questions. And yes, you can do all this on a calculator, but you need to show all of your steps, including plugging things into the formula. If you go to our lovely stat button on the calculator, you go to tests, and you'll see 1 proportion z interval all the way down. You'll enter x, which was the number of successes, which in this case was 144. You would enter the sample size. And then your confidence level, you need to put it as a decimal. So for 95% confidence, you would put it as 0.95. I'm going to skip over to example 4. I highly encourage you try those other examples that are on there and then ask me for help if you're struggling with them. But I think you have enough information to kind of get through that. But example 4 is a different type of problem, so I'm just going to kind of cover it briefly. It does require the information from example 3, but you don't have to solve it before you do example 4. And what example 4 is asking is what sample size would we need in a follow-up study if we want a margin of error of 5% with 98% confidence? So we want a margin of error of 0.05, confidence level of 98%. P hat, that was given in example 3, is 0.27. Since we have a confidence level of 98%, I can go to my chart and find Z star to be 2.326. But now I need to know N. So I'm going to be working backwards. And this formula is given to you on your notes. And that is Z star times the square root of P hat times 1 minus P hat over N is less than or equal to our margin of error. We can start off by plugging what we know. Z star for the 98% confidence interval was 2.326. And again, let's see if this works. It wasn't working earlier. There we go. Close enough. That should be a 0.27 right there. And notice that we have to solve for N. That's going to be a little bit difficult, very mathy, very algebraically fun. But you've passed algebra. You know how to do this. First, we got to get 2.326 the other side. So we divide that. Then to get rid of that square root, we got to square both sides. And then if you flip both sides to get that n on top, you'll actually flip that less than or equal to sign to turn to a greater than or equal to sign. So I square it the other side and then flip both sides to kind of make this a little bit something more to work with. Then you take this bottom part and multiply it by the other side. And basically you get n is greater than or equal to 426.55 once you do all that math. So we would just say that a sample size of at least 427 is what we need for this once we've solved everything. Have fun with these problems. If you need additional help on the AP Classroom stuff, please feel free to reach out to me. Reach out to me through email, lauren.cardenas@sfdr-cisd.org. I am literally sitting here in a classroom all day waiting for your questions. So bring them forward, but please don't actually physically bring them. Stay home, stay safe. I will see you all eventually, and I look forward to actually seeing your videos over current events and stuff. Bye.